So here are the tender frames which we erected in the last part, and we want to take things a bit further now by adding the rocking platform to which we're going to mount the motor and the tender body. So this is the long part that's left on the fret. We need to cut this out as before. And there's an L-shaped piece which joins onto this for attaching the muff to, which got separated from the fret a long time ago, and if we've kept things carefully it should be ready to hand. And once cut out, of course, these parts will need any etched cusp removing and traces of burrs from the tabs that attach them to the main fret taken off with a fine file. So we'll skip over that and get to these holes. And there are several holes in this, 6 in total, and they all need clearance for a 12BA bolt. So we're going to have to come back with a cutting broach and open these out. Now this is a size of broach that I haven't used before in this project, so I haven't got a mark on to say what 12BA clearance is. But because I've got 6 of these to do, once I've carefully cut a bit, tested a bit, cut a bit, tested a bit, and got to the size, I'm going to get a felt tip of a different colour to the ones I was using before and mark off 12BA clearance on this broach. So that's it, that's a good clearance fit. I'll get my red felt tip, mark that on there, and then I can carry on with the rest of these. I'm sure you don't want to watch me doing all these, you'll have seen enough broaching out of holes by now. So we'll skip on to the last one. And this is the one at the other end of the main piece, and I'm having to go really carefully here because there's not that much metal. I desperately don't want to bend this. That's going to form the coupling to the loco. But of course any broached holes are going to need cleaning off with a file because the broach will raise a burr. And then with the shorter piece, before I fold it up, I'm checking again with a 12BA bolt that it will fit through those holes, not entirely trusting my mark on the broach. So that's that bit ready, and we can have a look now at how these pieces are going to fit together. So the idea is that the long flat piece will sit on the top, and that little mark there denotes the top edge of this. The L-shaped piece is going to fix to the underneath part of that, and then in the corner of the L we're going to mount a specially modified muff. So there's an unmodified muff so far, and that's going to act as the pivot so that this top plate with the body and motor on it can rock backwards and forwards about that point on the frames. The front end of this rocking platform, of course, is the loco to tender coupling, and that's going to insert into that little pocket that we made a while ago on the back of the loco frames and be fixed in place by another 12BA bolt. Now, because the metal is so thin and it's got to slide up and down the bolt, I do want to reinforce it at this end. I'm going to use a 12BA turned brass washer to do that. I'm going to solder that on the top of there. And to do this we need to use yet another cocktail stick. I'm going to push the washer onto the stick, and then with a pair of side cutters just chop off the end of that cocktail stick. And the reason I'm doing this is so that it can fit down into the hole on my soldering mat. And as I'm putting flux on the end of this pivoting plate, I'm double checking that it is the top of the plate that I'm soldering this to. That's the one with the line on it. So in goes the washer, hold it in place, solder, and bring in the iron. Now once this is soldered, I'm going to run my broach through it again to make sure this is a good clearance for 12BA. I want to have a smooth surface on the inside of this so that it will slide without catching on the threads of the 12BA bolt. And to help it do that, I'm going to bring in my larger drill again and cut a little rebate on both the top and bottom of this hole. I don't want any sharp edges that can catch. So once I've got a nice little chamfer on there, I'm going to come in and polish the inside of that hole with a smoothing broach. This is the belt and braces approach, I think. And when that's done, we can start thinking about joining these two parts together. Now if you look at the instructions, they call for a nut to be soldered to the top of the platform and a bolt to fix the L-shaped piece from underneath. Now there is only one good reason for using a nut and bolt to join these together, and that's so that you can undo them again when you realise that the instructions are leading you astray, telling you to align it with the front hole in the L-shaped spacer. You actually need to align it with the rearmost hole. But because I've done one of these before and I've worked that out the hard way, and I've never needed to unbolt it since, I'm not going to waste a nut and bolt joining them together. I'm actually going to solder them because I want a permanent joint here. So I'm going to bolt them together temporarily to help me solder them. I'm inserting the bolt from the top, and we'll see why I'm doing that in a minute. But once these are in place, I can spin on a nut, and I need to do this up tight. And because these are a good clearance fit, they'll hold it together at the rear end while I solder the front end or the leading edge of this. And I want to make sure that solder doesn't wick along and solder the bolt in place. That's how it's going to fit. So this is why I put the bolt in from the top, so the bolt head can nestle down in the hole in my soldering mat. And then make sure this is aligned perfectly along the length of the plate. Put some flux in there and solder, and just dwell long enough to make a joint at the front edge there. Unfortunately, I'm still able to undo this nut and bolt, so I need to separate those. I really should have used a shorter bolt for this. You can see they're just joined at the front. So spring apart at the rear. And then smother this with solder around all the sides. I'm going to put a fair bit of solder in this. I want it to wick underneath and make a good joint here. And I can tell if it comes through this hole in the middle that the solder's travelled all the way under. A bit down the middle of there as well. I'll start on the back edge and then I'll try and take it up the sides. What I don't want to do is get this plate to move at all, so I'm pressing down quite hard with my tweezers on this. So while you watch me very slowly soldering these pieces together, I shall explain to you the next bit of the instructions that I'm going to deviate from and why. So the leg of this L-shaped spacer that's sticking up at the moment has two purposes. Firstly, it's to locate the muff against, and secondly, it's as a mounting point for a piece of PCB frame spacer to go on the front side of it. Now, the instructions don't say why this PCB spacer is needed. I can think of two possible reasons. The first one is to centralise this platform at the rear end, but I don't want to use it for that because I've got washers for that purpose. The second might be to stop it twisting from side to side at the front end, and I don't want to use it for that either. So I am going to put some PCB spacer on the underneath of this platform to stop it twisting side by side, but I'm not going to put it at the rear end because I don't think that would stop it twisting. It's too close to the pivot point. I'm going to put it just behind the front axle. So this is the place where the PCB is supposed to get soldered. If we place this down on here, what I want to do is have my PCB much further forwards. In fact, I'm going to solder it just behind the front axle. So we're going to make this from Association 7mm wide PCB frame spacer strip because it's a bit more robust than the thin stuff that we've been using up till now. So I need to work out now exactly where I'm going to put this piece of PCB, and so I can use the lines on my cutting mat to line up the hole at the front of the platform with the front spacer hole on the frames, because they do line up together. And then I want to find a place that's behind this front axle, far enough behind it for it to clear the muff as it moves up and down, and hopefully so that it's not going to be obtrusive in the frame cutouts. So I'm just going to put a little scratch on here, and I'll make a proper mark later on, but just a scratch to tell me where it's going to go. So to make this little part, I'm using my digital calipers. I'm locking them at 3.5mm. I'm going to mark off a little piece on the end of here. Now I'm assuming that the end of this is cut square, and then I should have done this before I marked it, but just check with an engineer square that it actually is square, that I'm going to cut this off parallel. So I'll just saw this over the end of a piece of wood using my razor saw flat. Keep checking, and when I get almost to the end of this, I can move it back onto the board and cut through the last few strokes on there. So I feel when it just bends down and gets a bit floppy, I move it back and chop that off. Now this is going to leave a burr, and I'll need to file that burr off. So I'll do it roughly with a file, holding it in my hand for now, but I'll need to transfer this to my vise, I think, to dress these edges. Because I'm soldering this edge onto the underneath of the brass, I need to make sure that this end is truly square, because if it's at an angle, then it's going to lean over at an angle. And if I'm doing one side, I don't know which way I'm going to pick it up. I might as well do both sides and make sure they're properly squared off. That should do it. I'm happy with those. So that's the basic shape. I now need to mark off where this piece is going to overhang either side of that central brass plate. And so by using my dividers like this, I can scratch on some lines, and I'm only going to show you one side in the video, but you need to do this on both sides. So once those lines are there, they're showing where it's going to be soldered, and then of course, because this is going to be touching the frames at the sides, they need to be electrically isolated. So with the razor saw, I'm not cutting these off, I'm just cutting through the copper on the PCB, and hopefully no further than just the copper. So having found the scratch that I made before on this, I'm using a square to mark a proper line now, This is going to line up with the front edge of this PCB piece that I've made. And it's worth spending as much time as necessary to make sure that this is upright and perpendicular and centralized. And if necessary, just nudge it around a bit. You can't see the scribed line on here, but where my head is in real life I can see it there, so I can see this is straight. And only when I'm happy with this am I going to bring in some solder and solder this in place. I'm just going to do the front edge at the moment because there may be some adjustments needed later on. But that will hold everything nicely for now. So I need to test it, and it turns out that these frames are just slightly narrower than the PCB, so we need to file a bit off. And at this point, if it's not quite centralized, you can file off one side and even things up a bit. So it's a case of looking at it very carefully and filing a bit and testing a bit. Don't want to go too far. So that's a tight fit now. That's no good. So I'll file a bit off the other side. We need this a reasonably loose fit so that it can slide up and down without any impedance at all. So check that out. That's a good fit now. Turn the frame so they're the right way round, because they may not actually be the same thickness in between them at the front and the rear. And that's going to move up and down nicely now. I'm happy with that. So once we've got the basic fit right and we know that it's in the middle, we can solder the rear side of the PCB, hold it much more securely, and then of course we have to check that there is electrical discontinuity between the centre and the edge sections. And here on this first one I've checked, there is actually a short. So the solution to that is to come in with the razor saw and just give a few strokes, holding the razor saw against the brass edge there. And check again, and that short has now gone away. Test the other three. Always remember, I've got to do both sides of this. And everything is now good. And so one last little procedure to do with this. I'm going to dress these edges, put a little chamfer on the front and back and the top bottom of all of these corners, because I don't want anything to catch. I just want this to be able to slide as smoothly as possible up and down. Now, as we've already established, the tender body is going to be fixed to a plate that's bolted to this pivoting plate, and the heads of the bolts are going to be underneath it like this, and they're going to have to pass freely through the holes in the front and rear spacers. Now, I've reamed this one out a little bit, but actually it needs to be much bigger, and this is my biggest cutting broach, Gargantua, which I've used all the way up to its very end to make this hole. It's about 3mm wide, so quite a bit of broaching has gone on with there, and also on the rear hole broached it until it broke through the edge and then filed it with a round file. So here comes the muff, and normally with a muff what we need to do is we need to file it down to size so that it would fit in between the phosphor bronze bearings, because they're a little bit wider than that. However, this is going to make this pivot, and we've got the opposite problem. It's too short. So we're going to have to get some washers or something to space that out, to hold it in the middle. Maybe that's what the PCB pad was for. Maybe it was to hold it central rather than to stop it wobbling. Anyway, to prepare the muff, first thing we need to do is chamfer the edges with a drill, and then we've got to file a flat on it. I'm holding this in my vise on its end, and I've just managed to push it down with my file actually. I'm trying not to grip this too tightly because I don't want to squash it. I have to wind it in a little bit tighter. So I've been careful to make sure that this is flat on the top, and as I file this down, I'm looking at whether the edges of this flat are parallel or not. If they're parallel and straight, this means that I'm filing a proper flat on here. If they pinch in at one end, then it means the other end is filing further down, the sort of the fat end of this, what's no longer a parallelogram. It's turning into a trapezium if I'm filing wonky. But so far, I seem to be doing all right. The trick, as ever, is to take it slowly, carefully, and keep checking. I'm not putting much pressure on this. And I can just detect it's getting a little bit fatter at this end that's nearest the camera. So I need to put a bit more pressure on the end that's furthest away. It's very easy to go too far with this. Experience and practice is telling me how far I need to file this down. What I don't want to do is keep taking it out of the vise in order to measure it. So if the jaws of a caliper can go in there and take a measurement, then so much the better. But I'm just trying to even this up now and file it at the far end. You can see the shape where it's shiny. That's the edge that I'm filing. What I can't do is leave it with that diagonal line across the middle and have a shiny bit and a rough bit, because that will say this is not flat. I have to have the same sheen reflecting in the light to make sure that this flat is truly flat, if I want to do a proper job of it. I think I'm just about there with this now, so I can remove it from the vise and check whether I really have got this flat and parallel to the hole that goes up the middle of the muff. And to check that, I'm going to use a drill that's slightly smaller than 1.5 millimeters, so it slides easily into the hole. And align this with a ruler, or in this case the edge of my set square. I'm going to press on this hard and look down the edge of it and say, is that parallel? If my drill's too small and it slops around in that hole, I'm not going to get any usefulness from this. But it's always worth checking to get this right. If it's not flat, you'll forever have a tender that's sitting wonky, and you don't want that. It's better to throw them off away and start again and do another one. It does take practice. So once I'm happy with it, it's time to glue it on. And Araldite, this is Araldite Super Glue. I think this one's discontinued now. I think it's replaced by something called Araldite Instant. It's even more rapid than Araldite Rapid. That's the point of it. So I want this to set quite quick. And I'm putting a fairly good dollop of this into the corner here, covering over that hole that if I was silly and I bolted that L-shaped spacer to the main platform with that. So I use my drill as a handle to get this in place, squash it down. You'll see that the Araldite oozes out of the sides. Get another clean cocktail stick just to wipe that out of the way. And in fact, I could use that to squash back into the corners. But I've got a couple of minutes with this, that's all, maybe 90 seconds to 2 minutes to just move this around. And so what I need to do is get my drill in position, and while I've got those few seconds, precious seconds, line this up with the cutting mat squares again to make sure that the drill is at right angles to the platform, because it's no good if it's going to be wonky. I might need to do some squishing around with this, and if worst comes to worst, I can always put a tweak on that spacer. So that's almost 90 degrees, not quite. Just a little tweak there to bring it to 90 degrees. And then if I bring the camera down, we need to get our heads down and look along this to also make sure, as well as right angles that way, it's lying flat. So again, tweaking may be necessary to get it to lie absolutely flat so that that bar is flat, because otherwise we're going to get a twisted, wonky, tender body. And the final thing is the muff central? Otherwise the tender body will be off to one side. So just checking, tweaking while this glue goes off. And not totally happy, I'm just going to give it a little nudge to the left as we look at it. And just to confirm, bring in the ruler there, put it on the centre line and double check that that muff is indeed central. If it's not, the glue will have gone off by now anyway, so I have to peel it off and start again. You see here, once I was happy with that, I mixed up another bit of glue and gave this muff a comb over. We can see here that that muff is too short and it's wobbling around, so I've got my 12BA washers ready for this now. One each side, and they're the perfect thickness. Unfortunately, 12BA washer is about 1.4mm up the middle, not the 1.5 it needs to be. So having a very good watchmaker's vice with good jaws, I am able to hold this by its edge and broach this hole out slightly to 1.5mm. So I'm just rolling the broach now towards me, anti-clockwise, holding my finger there to stop this washer trying to climb out of the vice. This is quite a delicate operation. If you haven't got a good vice like this, I don't know how I would do this. Holding it in pliers is probably not really an option. I have to get a bigger washer, I suppose, but that may then need filing down. But I'm just about up to my mark now for 1.5mm. I'll twiddle that around a few more times, and then once I'm happy, get a length of axle steel and try it out. I was being very careful there, by the way, to make sure I wasn't cutting into the vice jaws with the broach. But yep, that's good. And of course, because I've been broaching it, there will be a burr, and the easiest way to do that is to pick it up on the fingernail and rub it on top of the file. And remember, I've got two of these that I need to make, one for each side. So here are some half axles that I have made already, lined up next to these. And these little guys I made some time ago actually on my lathe. If I'm making one, I'll tend to make half a dozen at least and just put them in a little bag and keep them with my bits of loco chassis components. Now, having just mentioned the dreaded L word, the good news is that you don't actually need a lathe to make these. All you need is a file and a mini drill and a vice and a saw. They're quite easy to do. These are chamfered at one end, and the chamfer that we put on the muff before we glued it in place will engage with that chamfer and help them seat home. So to make these, take one length of axle steel, and these axle steels, they normally come chopped off with big choppers, so the end will not be flat. So we need to file the end flat before we start. And once that end is flat, we'll have raised a burr on it, probably. So I'll close the jaws a little bit, rest it on top, and then file off that burr. So I'm going to roll this round with the finger of my left hand while I file with my right hand and go around a couple of times. I'm not putting a chamfer on this, I'm just very lightly taking off the burr that I raised by filing the end flat. So here's a quick before and after of an untreated rod as it comes from the shop and a treated one. Okay, so I need to make these 3mm long. So I'm marking with a blue pen here and then with my calipers set to 3mm, just put a little notch on there, a scratch mark in the blue, which will tell me how long this needs to be. And I'm going to hold the short end, the other side of the vise, and hold the long end with my fingers. And I'm using a very fine piercing saw blade here to cut this off. You don't have to use a piercing saw blade. You can use a slitting disc, razor saw, whatever you're most comfortable with, I guess. So very gently when we're getting to the end of here, because we don't want to snap the blade. And then dress this end, file it flat. Okay, so we're going to have a flat end with a burr on it, and a flat end that we deburred. And the deburred end I'm going to insert into my mini drill, and then with a file I'm going to take the burr off the other end, the cut end, and put the chamfer on it. So this is just a couple of light touches with the file, and that's what I end up with. Now that wasn't painful, and it didn't need a lathe. Oops, here's one thing I forgot to do earlier, which is to drill a hole in the middle of the muff. So that's just going through one side of there to the middle using a 1mm drill bit. The size of the drill bit's not crucial actually. The reason I need to do this is because when I put these half axles in at both sides, air will get trapped between them, and as they push in, if that air hasn't got an escape hole, it will compress and will spend the rest of its life trying to push these things back out again. So that little hole helps the air escape. So I'll put one washer in place, balance it on there, put this carefully in the hole, get the half axle, and remember it's the chamfered end down. They are tricky little things. Chamfered end down into the hole, and now we need to get that through the washer, and the chamfer will help it find the centre of that washer. And if it can't, we might need to just do a little bit of tweaking, push the washer around, on it goes, and then push it in and find and engage with the muff. And then it's a case of push this down till it engages and grabs a bit. Doesn't need a lot of force, but to push it all the way home it needs a bit more force, so we'll do that with something substantial on a hard surface. And then we should be able to slot this other washer in place, and this time I can use the end of my tweezers to line up the holes. Another half axle, find the hole in the muff, check everything's okay, and then squash it down into place. Easy as that. Of course, when I've squashed the other side, it'll have squashed the frames up, and this will now be proud. So that needs squashing down again. Now I've got something else in there. And of course I will have squashed these frames together, as I said, so I'll need with tweezers just to tweak them back out again so that this thing isn't binding tight. And hopefully this will move quite freely. I could spend all day tapping that up and down like a Morse tapper, admiring my handiwork. Check it from the front though, make sure it's centralised. Check it from underneath, double check with a couple of 12BA bolts that the heads do indeed fit through these big holes and it can move up and down quite freely. That's good at the front. Check at the back. That's got enough clearance. Phew, we don't have to take it all apart again. That's good news. So care with putting it together, measuring everything, checking everything as you go. This should be the result. We're seeing some real progress now, and our thoughts can start turning to the wheels next.